Alright, in this video we want to talk about something called variation, and there are four main types of variation. The two most basic kinds, the two kinds that the other types 3 and 4 are based on, are called direct and inverse variation. And the idea is not that complicated. It's an idea I'm sure that you've run into before. Direct variation means that you have two numbers that do the same things. If one of them goes up, the other one goes up too. If one of them goes down, the other one goes down too. So I'll give you a couple simple examples of things that are directly related. Let's say, for example, the hours that you work and the pay you receive. Let's suppose that Y represents your salary, and let's suppose X represents the hours worked. There's a direct relation between those. If, let's say, you make $20 an hour, so that means Y is equal to 20 times X. If you work for 10 hours, you'd have 20 times $10 or $200. Okay, what happens if X goes up? So instead of working for 10 hours, let's say we work for 20 hours. So we just increase the X. What's going to happen to the Y? Y is going to go up from $200 to $400. So that's what it means when we say things are directly related. One goes up, the other one follows. If one goes down, the other one goes down too. Okay, another example, of course, like it says there, would be the amount of time you spend practicing. Usually you're going to get better and better at whatever sport you're playing, and vice versa. If you decrease your time practicing, your ability level is going to go down too. All right, the second type of variation is called inverse variation. Inverse is another word for opposite. So as one variable goes up, the other one goes down. Okay, so for example, in this case, by the way, the equation for this top one, the basic equation is this: y equals some number, k stands for any number. In this case, k was 20 because we were making $20 an hour, times x. And that's the setup for direct variation. For inverse variation, it looks like this: y is not getting multiplied, or y is getting multiplied by x this time, unlike up here where k was getting multiplied by x. So when they're inversely related, they're on the same side of the equation. When they're directly related, like up here, they're on opposite sides. So example of things that go in opposite directions: the amount of time that you spend learning to drive is inversely related to the risk or the probability of you getting in a car accident. If you spend more time practicing, you probably have less car accidents. The amount of time you spend shoveling is inversely related to the amount of snow in your driveway. The more time you spend shoveling, the less snow in your driveway because you're clearing it off. All right, so let's do, there's four basic examples I want to show you, one of each: direct, inverse, joint, and combined. And joint and combined are just variations or expansions on the first two. So this one says if y varies directly with x. So right away we know that we're going to be using this equation. This is the equation for direct variation. And there are two steps in all these problems. The first step is to find k using the two values given. And I'll explain what that means in just a sec. Find k using the two values given. Okay, and then second step is use k to find the missing value. So two steps: find k using the two values given, then secondly, use k to find the missing value. So what do I mean by the two values given? Let me use a different color so this is not too much red here. So there's two values given: y equals 24 when x equals 16. There's our two values given. So I'm going to plug in 24 for y, and I'm going to plug in 16 for x, and there's that k. Okay, now it says find k. Well, here we would find k if we just divide it by 16. And k is 24 over 16. When you reduce that, it reduces to 3 over 2. Okay, so we've taken care of this step. We found k. Second step, so we'll call this step 1. Okay, we'll cordon that off. Step 2 is now we use the k back in this same equation. It was y equals kx up above here, but now I'm plugging in what we found k to equal. K is equal to 3 over 2. And now we're asked to do this. We're asked to find y when x equals 24. So that means y equals 3 halves times 24. And at this point, what we can do is cancel. The 2 goes into itself once. It goes into that 12 times. And 12 times 3 is 36. And that's what y equals. So that's how we would solve that problem. All right, see if you can pause the video and try these other ones. And I'll just give you a hint for this one. Again, the formula for this is, I want to use blue right there because it's in blue. The formula for this one is going to be y times x equals k. That's the one you use for inverse. See if you can pause it and try those other three that you see there. The one, I'll give you the other two as well. The one down here, when it's jointly, it's going to be y equals kx, same as the above, but then there's a second variable, so kxz. And then I'll give you the third one in a second. It's a little bit of a challenge to figure out this, this fourth one right here, but see if you can do that. All right, so let's try same two steps, by the way. We're going to find k by using the two values given. So what are the values that they're giving us right here? They're giving us y equals 24 again and x equals 16 again, but slightly different now because now on their opposite sides. So 24 times x is 16. Okay, 24 times 16 is going to be 384. So that's what k equals right there. K equals 384. And remember, k is a constant. So k is always going to equal 384. That's what we're going to use to help us solve the second part of this. So step 2 is this: use k to find the missing value. So let's go back to this original, but instead of equaling k, we know that k is 384. And then we use this other value. Okay, now x is 24. So 24 times, we don't know y yet, 24 times y equals 384. If I divide both sides by 24, I would get y equals 16. Okay, let's see if this makes sense. So x went from 16, x was 16, and it increased to 24. So inverse relation means as one goes up, the other goes down. X went from 16 to 24. Y started out as 24 and went down to 16. So one of them went up as the other one went down. That seems to agree with what we said should happen. All right, the last two, joint variation and direct variation, very similar, just really with one extra step. So this one says if y varies jointly with x and z. So this is another word for directly. The only difference now is that we had this part originally, but we're just adding a z because y is varying with two variables this time instead of just one. Our first step is still the same. We're still going to find k by plugging in the stuff they give us, and I just underline what they gave us. They gave us y is 24. They don't give us k. They give us x is 4, z is 1, and we don't know k. So 24 equals 4 times 1 is 4. If we solve for k right there by dividing, we would get k equals 6. There's our first step. Second step is we go back to the same equation. I'm now plugging in, sorry, that should be a 6, not a 4. I'm now plugging in 6 for, actually that shouldn't be a k either. Plugging in 6 for k because we just found that in the first part. And now we're going to be given x is negative 2 and z is 5. So let's do that. So y equals 6 times x is negative 2, z is 5. 6 times negative 2 is negative 12, and negative 12 times 5 is negative 60. And so that is what y equals right there. Okay, that's how you do joint variation. The last one is called combined variation. This is where it's a mix of direct and inverse. So let's read this carefully. Y varies directly with x. So we've done that before. That was the very first one we did. Y varies directly with x is that right there. And at the same time, it varies inversely with z. Well, remember up above, let me move that so you can see it. Remember up here, when things vary inversely, you have them on the same side. So when y varied inversely with x, it was y times x. In this problem that we're doing in purple, y varies inversely with z, so it's going to be y times z, or I'll just put it as z times y. Otherwise, our steps are the exact same. First step is always to find k, find what the constant is using, in this case, 3 values given. Before we said 2 values. Since we have 3 variables here, we need 3 values. So y equals 6, x equals 24, z equals 2. So z is 2 times y is 6. We don't know k, but we do know x is 24. Okay, that's going to be 12 equals 24. Sorry, I should have said k right there. We don't know k. So 12 equals 24 times k. If we divide by 24, we're going to get k is equal to 12 over 24 reduces to 1/2. So there's our first step. Okay, second step is plug in the other values given to find using k that we just found. So here's our second step. We're going to use that exact same equation, zy equals kx. That's the one that we needed to use. And we just found out that k is 1/2. What else are they giving us? They're telling us y is 18, z is negative 3. So negative 3 times 18 equals 1/2, and we're being asked to find x. We don't know that. So negative 54, that's negative 3 times 18, equals 1/2 x. Now how do we solve that for x? We would divide by 1/2, but that's like multiplying by 2. So negative 54 times 2 gives us x, which is negative 108, and that is how we solve variation problems. Hopefully it makes sense.